The trapezoidal rule, like the other types of Riemann sums, is another way to approximate the area under a curve. The actual rule in mathematical terms is shown here. When f is continuous on the interval, then the integral of a to b, f of x dx, is equal to b minus a over 2n times all the things in the bracket. But that looks kind of intimidating, so we're going to break it down a little bit. The formula for the area of the trapezoid is shown here. Is a equals b1 plus b2 times h, all of that over 2. Now the b1 and the b2 are the lengths of the parallel sides of your trapezoid, and h is the height. Here's a graph to use as a first example. I've drawn in the trapezoids to help visualize. You take the area of each trapezoid and you add them together. I have plugged in all the heights and all the base values into our equation so that we can add them up the way we need to. You do your first parentheses, just like in the order of operations. You multiply it all out, and then as your answer, you get 25 over 2. So that is the area under this curve. Now let's do a second example, this time using a table. Here we're going to break it up into 5 equal subintervals. So we're going to draw it out on our graph. We have 0 to 200, 200 to 400, 4 to 6, 6 to 8, and then 800 to 1000. Now let's start with our first interval, which is going to be 0 to 200. Now our B1 and our B2 are going to be 125 and 120 respectively. And our h is actually going to be the difference between the two x values. So that would be 200 minus 0, which is still 200. Now when you plug that into your area of a trapezoid, like what we've been doing the whole time, you get 20,000. You do that for all of your other intervals shown here, and you add them all up, and you get the area. See, you do all of your math just like you did on the last one, and I've changed the colors a little bit so that you can tell which step is which. I know it's a little confusing, but you do all your math just like you did in the last one, and your area under the curve is 8850, and so that would be how much space is under the curve, even though we can't actually see it here. Here is a third example, which is an AP type problem. So this is the kind you would find on your AP exam. This one is a little bit trickier because the intervals are different. We have, instead of it being all the same number in between, we have 2 to 3, 3 to 5, and 5 to 8. So that's differences of 1, 2, and 3, which is a little bit trickier, but we can still do this. You just plug it in just like you did with the last one, and here's your y values added together, and here's all of your h's that you got from your x values. Do your order of operations just like you've done on all the other ones, and once you finish that, you get it all adds up to 430, which is C. So let's circle that here so that we feel a little bit more satisfied. As for this topic in the AP exam, it is almost certain that it'll be on there. I've taken the exam for 2019, and I've taken a bunch of practice tests and some of the exams that have been released from years past. There is always at least one question about trapezoidal sums on there. There's usually even more. They could be multiple choice or free response, calculator allowed or not. But above all, know that you can, in fact, do this no matter how scary it may seem. You have to believe in yourself. Don't push yourself past your limit. And know that you've absolutely got this.